these are going to be some straightforward examples of how functions work. Make sure you're copying them down. So, number 1. If h of x equals 3x minus 2, find. So we'll do these one at a time. So, h of 2. So h of 2 means that the x is going to be replaced by 2. So here the x has been replaced by a 2. So that means in my function, the x is going to be replaced by 2. Okay, so it's basically a substitution. If the x has changed to a 2 in the hx part, then any x's in the function also change to 2. So we get 3 2s are 6, minus 2, so we get 4. Okay, so it's just a substitution. Another one, h of a third. So again, the x has been replaced by a third. So I just replace my x by a third and the function in this. So x becomes a third. 3 times a third is just 1. So we get minus 1. And then h of y, for example, so a little bit funny, just mixing up a little bit. All that happens if the x has been replaced by a y, this x also gets replaced by a y. So I just get an expression for this, 3y minus 2. So it doesn't matter what they put in the bracket. If they're replacing the x with a number or a letter, we just replace that letter x with that number or letter that's put in place here. So these are the most simple kind of questions, like your 1 markers. Number 2. So just a little bit of different notation. This function is going to be called g, such that x is mapped onto the square root of 5 minus x. So don't let all this stuff confuse you here. This is just the same as writing gx equals root of 5 minus x. Okay, it doesn't mean anything different. It means the same thing. It's just them trying to catch you out and confuse you. Okay, it just means exactly the same thing. So part A, let's find g of 1. So g of 1, all this means is that we're going to sub 1 in to our function. So wherever there's an x, we replace it with a 1. So this x gets replaced by a 1 because this x has been replaced by a 1. And we get root 5 minus 1, which is root 4, which is 2. G of 5. Same idea. So we replace the x. This time we replace it with a 5, and this will give me root 0, which is 0. 0 times 0 is 0. And part C is g of minus 4. So again, the x has been replaced by minus 4 here. So we're just going to replace Rx with minus 4. And just be careful, because we've got a minus in there already, so it'll be minus minus 4. So this will become 5 plus 4, or 9, and we'll get 3. So exactly the same idea. Don't let this notation confuse you. It's just a different way of writing the same kind of thing. Number 3. So again, we're given a function, so given fx equals 7x plus 5, and we're given a different function, this time gx is 6 plus 2x, so just 2 different expressions. Find the value of x such that f of x equals g of x. So if fx equals gx, this implies that fx, which is this thing here, fx equals this, is equal to, so fx equal to gx, which is this. So fx, my 7x plus 5, is equal to gx, which is my 6 plus 2x. So I can just equate the two functions make them equal to each other. That's what this means. fx equals gx. There's fx. There's gx. And they're equal to each other. And then solve. So we can minus 2x from both sides. Minus 5. And then divide by 5. So x equals 1/5. Or I know some people prefer your decimals. You could have 0.2 here. So again, a slight variation on a functions question. They're giving you two functions this time, and they're telling you where are they equal. So we can just put them equal to each other and then solve that equation that follows from that. Four. So if hx equals 3x plus 1, find the following. So h of x minus 1. So not always. We had one at the start where we replaced the x with a y. This is the same kind of idea as that. So don't let this worry you. If x is being replaced by x minus 1, that means wherever I see an x, and whatever I was doing to that x, I'm now going to replace that x by x minus 1 and do exactly the same thing to the x minus 1. So 3 times x, the x has changed to x minus 1, so the x changed to x minus 1 in here too. And then I can expand and simplify if I would like to. So I get 3x minus 2. So it's still the same idea. It's not a number that I'm subbing in, it's a letter. So I can't find its value, but this is the best I can do. It's an expression for h of x minus 1. h of 2x. Same method. So the x has changed to a 2x in here. So the x in here will also change to a 2x. 3 times 2x is 6x. So I get 6x plus 1. Hopefully getting the hang of subbing in h of minus x. This time we replace the x's with minus x's, so wherever there's an x, I replace it with a minus x in brackets, just like your normal substitution. Use your brackets. Minus 3x plus 1 or 1 minus 3x. And then part D, h of x plus 5. Okay, now this one's a little bit different because you'll notice h of x is still h of x. I'm not replacing the x with anything apart from itself. So h of x plus 5, well, here is h of x at the top. So I'm just taking that. There's my h of x plus 5. Means I'm adding 5 onto that. And then I can simplify. So it's only when they change things in the bracket does the x change. If this stays the same, h of x plus 5 just means I'm taking whatever h of x is, which is this, and I'm adding 5 on. Okay, and I get this. So this is just an example where I'm subbing in letters rather than values. And then number 5, if it'll let me. Remember, pausing the video if you need to, you can go through things, or if you need time to write things down, then you should have that time. So if fx is 5x plus 7 and f of a is minus 3, find the value of a. So again, slightly different, but we should be able to work out what's going on here. So if f of x is 5x plus 7, f of a, well, what's happened? The x has changed into an a. So f of a must be the same as this, but with the x changed to an a. So just like the ones above, if you change the thing in the bracket, then we change any x's become that letter in the bracket. So f of x is 5x plus 7. F of a means I'm replacing the x with a. But f of a is equal to minus 3. So I know that this, there's my f of a, this must be equal to minus 3. F of a is 5a plus 7, and f of a equals minus 3, therefore 5a plus 7 equals minus 3. And then I can solve minus your 7, divide by 5. So these are all the kind of basic functions questions, substitutions. We're going to look at some values that need to be excluded from the domain next, so the last little bit of the notes. So question 6. So which numbers must be excluded from the domain, okay, of the following functions? So f of x is 1 over x. So there's two things we bear in mind when we do this, and they are that we're not allowed to divide by 0, and we're not allowed to square root a negative number. Okay, and they're the two things. Whenever they ask about things being excluded from the domain, these are the two things that should be on my mind. So here, if you can't divide by 0, whatever makes the bottom equal to 0, so in this case just x equals 0, that's what I've got to exclude. So I'd say exclude x equals 0 from the domain. If x is 0, I'd end up with 1 over 0, and then I've got problems. I'm not allowed to divide by 0. Same kind of idea. So I'm not allowed to divide by 0. So if x minus 2 is 0, that's the number I'm not allowed. So if I just solve that, and you can just see from looking at this, if you put x is 2 in, you're going to get 0 on the bottom. That's not allowed. So here we would exclude x equals 2. Okay, we're not allowed to put that into the function because I'll get an error with my calculator. Dividing by 0 is undefined in maths. And then similarly, if we've got things like square roots, a little bit trickier because there's more than one value, but we're not allowed to square root a negative. Still just about the top of our screens here. So I'm not allowed to have x less than 0. Now this is a range of values because there's lots of, you could have -1 or -2 or -7.6. There's an infinite number of values that you can exclude here. So here we just put whatever is underneath the root. If we make that negative, i.e. negative means less than 0, that's what negative is by definition, we can exclude those values. Again, same kind of idea, I'll just use I because I'm running out of letters. 1 plus root of x minus 2. So again, the thing that matters here, whenever you're seeing about excluding things, take the square root. I can't have a negative, so the bit under the square root, that's the bit I want to exclude. I want it not to be negative. So here I'll exclude x anything less than 2. If x is 2, it's okay because I'll get 0 and I can square root that. But if x is less than 2, let's say if x is 1, I'm going to get negatives and I start to have problems. All you have to do is put the bit under the square root less than 0 and then solve that just like an equation. Part E. So this will be jx, last one, which is root of 4 minus x. Again, I'm not allowed to square root negative. As soon as I see the roots, I should be thinking that's what I'm excluding. So I've got to exclude. So I can't include. If this is less than 0, that's not allowed. And then just solve this. So add x to both sides. So I'd have to exclude anything bigger than 4 for x. Think about it. If you let x be 5, I'm going to be square rooting a negative. Okay, I'm not allowed to do that. I'm going to not get any real values, which means no solutions to this. So exclude x bigger than 4. So these are the kind of main questions at the start of the functions questions. Subbing in values, solving little equations, and also what values must I exclude from the domain. I'm not allowed to divide by 0, so you can just make the 0 at bottom equal to 0. And I can't square root a negative. That's the same as saying I can't have the bit underneath the root being less than 0. Bit underneath the root, less than 0. Bit underneath the root, less than 0, then I can solve inequalities. Remember, I'm solving inequalities just like an equation. That's it.